Okay, so year 12, considering you've got your mocks coming up next week, I thought it might be worth just going through a bit of integration. So we're going to go through a reasonably difficult, like multi-step integration type question, like the sort you could get in your exam. So to start with, this is the whole question here. I'm going to break it down a bit on the next slides. But the first thing to note, in total, this is like a 10-mark question. So that's like indication number 1. There's going to be quite a lot of work to do. So we'll start with part. So with part 8, then what are we told? We're told this shape here shows a sketch of part of the curve with this particular equation. And then we're told that the curve has a turning point at the point A. So the first thing we need to think is, oh, when we see turning point, when we see turning point, that is our hint we need to differentiate. So to find a turning point, we differentiate what our equation of the line. So dy by dx is going to be 12x squared plus 18x minus 30. That's our differentiated form. And then in terms of finding the turning point, we set our differentiated form equal to 0. So 12x squared plus 18x minus 30 equals 0. And then because it says show that, I'm just going to go about like factorising properly. So let's just have a look. 12, 18 and 30 have 6 as their highest common factor. Then we get 2x squared plus, ignore that. We get 2x squared plus 3x minus 5 equals 0, like that. And when we factorise that, we are going to get 2x plus 5, x minus 1 equals 0. So then we either end up with x equals 1, or we end up with x equals minus 5 over 2. And we know in this case x has to be 1, because if we just look at our figure on the graph, x is greater than 0. It's like x is going to be positive. So I would just be like x is positive. Therefore, x equals 1. So that's part A of that question. Okay, so then for part B of this question, what are we told? We are told the curve crosses the x-axis at 2, 0 and minus 1/4, 0. So I'm going to label those like that. Lovely. Then what are we told? We're trying to find the area of the region R. Fine. Now, problem being, to integrate to get the area under curve between particular limits would be fine, but we can't just integrate between B and C, because if we did that, we'd get this entire area, and we don't want this little section here. So when that's the case, what you need to do is you need to split your shape up into kind of a bit that's bounded by a curve and a bit that's simply a triangle or a trapezium or something that looks like that. So in this case here, what I can see is I can split it into this triangle, which I'm just going to call 1, and then this area between A and C, which I'm going to call 2. So I can work out the area of both of those shapes and add them together. And the fact that this is 7 marks is an indication of the amount of work you're going to need to do. So for shape 1, it's a triangle based on side divided by 2, blah, 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 blah. If we remember from before, A is the point 1 something. So to find the y coordinate, I'm going to substitute x equals 1 into this. And I'm just going to do that now. We get 4 lots of 1 cubed plus 9 lots of 1 squared minus 30 lots of 1 minus 8 gives me minus 25. So this here is minus 25. Now we know that then. That means if this is minus 25 and this here is 0, this line is 25 units down. So like its height is 25. Its width is, well, if this is 1 and this is 2 is 1, so it's 25 times 1 divided by 2, which is 25 over 2 slash 12.5 units squared. For shape 2, we are going to integrate now because we've got a curved bit. We are going to integrate 4x cubed plus 9x squared minus 30x minus 8 between our limits. So my limits are 1 and minus 1/4. So 1 and minus 1/4. So first of all, when I integrate, I'm going to get, I add 1 to the power, so 4x to the 4 over 4 plus 9x cubed over 3 minus 30x squared over 2 minus 8x over 1. Now, we don't have the plus c, we only have the plus c when we're doing indefinite integration. Here we're doing definite integration because we're integrating between particular limits. So now we've got that, I'm just going to simplify my integrated form. So that becomes x to the 4 plus 3x cubed minus 15x squared minus 8x. And now what we do is we substitute in x equals 1 and we substitute in x equals minus 1/4. So when x equals 1, we are going to get, I'm just going to do this on my calculator, 1 to the power of 4 plus 3 lots of 1 cubed minus 15 lots of 1 squared minus 8 lots of 1. I get minus 19. And then when x equals minus 1/4, let's try this now. I get 3 lots. Minus 15 lots. I get this. I get 261 over 256, a number just over 1. And then we subtract to get the area. So we're subtracting like that, which gives me something like this. Minus 5125 over 256. Now just be super careful here and think. This area, it doesn't make sense to have a negative area. The reason we're getting a negative area here is because we're looking at the area underneath, and we're normally looking for the area underneath the curve. Here it's given us the area above the curve, and because of that it's given us a negative. We just need to remember that this bit, just switch to highlighter, should actually be positive for when we're working out the next step. So then our final way of getting the final answer for R, all we need to do is add together this 12.5 or this 25 over 2 plus 5125 over 256. And when we add those both together, we get, I'm just going to write this down as a decimal. The question wants my answer to 2 decimal places, which gives me 32.52 to 2 decimal places. That type of integration question there is probably one of the harder types of integration questions you might get. There's quite a lot going on. Hopefully that's been helpful and you should be able to use that to have a go at the rest of the questions today. Let me know how you get on as ever. If you need anything at all, please just let me know.